It's Friday, the 13th of June. My name's Juan Brown. You're watching the Blancolirio channel. We're up here in the mountains of Idaho, and we're getting more information about the Ram Air Turbine and its possible deployment in the 787 crash in India. We're getting this evidence primarily through audio information. Now, this is what a Ram Air turbine sounds like when it's deployed. We're going to talk about the purpose, the function of the Ram Air turbine, and what exactly triggers a Ram Air turbine to be automatically deployed in a 787, because this can give investigators a lot of different things to start looking at. So this comes from PDX Spotting. This is an American 787 rat deployed. Listen. Did you hear that very distinctive sound of the rat? It sounds like one of the propellers on our Husky aircraft that we're flying out here today at full takeoff power. Now, this is the audio file from the crash of the 787 extracted, and this is on Tech News Australia. Listen to this. Did you hear that? One more time. That's the sound of the Ram Air turbine being deployed. So to me, in my opinion, this appears that this jet had some major problems taking off or prior to takeoff. The Ram Air turbine is located right there on the fuselage behind the landing gear. It's a constant speed propeller, so it's a variable pitch propeller to allow it to operate at maximum RPM even as the speed of the aircraft decreases. It windmills like a pinwheel, but it turns that RPM up so high, that's what gives it that distinctive sound. That's the tips of these propeller blades nearly reaching the speed of sound, giving that loud brapping noise as it goes by. So what does the Ram Air turbine do? The Ram Air turbine specifically gives some hydraulic power to the center hydraulic system and some electrical power to the 787 jet. The 787 is an electro-hydraulic jet. It really relies on electrical and hydraulic power in order to maintain control of the aircraft. Remember, there are three hydraulic systems in the 787, left, center, and right. The left and right hydraulic systems have engine-driven hydraulic pumps like any other airliner, but the rest of the pumps in the hydraulic system are electrical hydraulic pumps. So there's an electrical demand pump on the left system, an electrical demand pump on the right system, and two electrical pumps on the center hydraulic system. Remember, any one of these three hydraulic systems is all that it takes to operate the 787. That's the redundancy built into it. Generally, the left hydraulic system powers some flight controls and the left thrust reverser. The right hydraulic system powers some flight controls and the right thrust reverser. The center hydraulic system is, again, the heavy hitters, typical of a Boeing design, includes the flaps, nose wheel, steering, main landing gear, and some additional flight controls. So that's how you can operate the 787 with just one operational hydraulic system. And the RAT will give you enough hydraulics to do that. Now, when you're taking off in something like a 787, this is the highest demand you can demand on a hydraulic system. The RAT is not designed to raise the landing gear in the event of a takeoff or a takeoff emergency. It's just designed to provide enough hydraulic power to maintain control of the aircraft. Now, here's the important part that nobody's talking about regarding the RAT. When are the times that the RAT is automatically deployed? You can always manually deploy the RAT by pushing the button up in the cockpit. It's spring-loaded. It is spring-loaded via the hot battery bus, so it's always hot. That's why when you're doing a walk around these Boeing jets and you see the big red box around the RAT, don't walk underneath that thing. You wouldn't know what a rat was if it hit you in the head. Now, there are several different things that can automatically deploy the rat in the 787, and it's different than other Boeing aircraft. First is the traditional one, dual engine failure. Makes sense. If you have dual engine failure, you're going to automatically deploy the rat. But also, 1, 2, 3, there are 4 more conditions that can automatically deploy the rat. Low pressure in all 3 hydraulic systems. If you lose hydraulics, all 3 hydraulic systems, you're going to get the rat. Loss of all electrical power to the captain's and first officer's flight instruments. Again, the 787 is an electro-hydraulic jet. It needs this electric and hydraulic power in order to continue to operate it. So a loss of all electrical power to the captain's and first officer's flight instruments will automatically deploy the rat. A loss of all 4 electric motor pumps and flight control system faults during approach. All 4 electric motor pumps, that's what we're talking about on the hydraulic system. Remember, we had the 2 engine-driven pumps, and then we had 4 electric motor-driven pumps. So if you lose all 4 of those in the hydraulic system, you're going to get the rat. Also, this odd combination here, a loss of all 4 electric motor pumps of the hydraulic system, as discussed earlier, and an engine failure on takeoff. So that can deploy the rat as well. So because it's becoming more apparent that this rat was in fact deployed in this takeoff crash, this tells me that this is going to be a much more complicated accident investigation, and there was something terribly wrong with this 787 jet, and we need to find out really quick what it was that went wrong with this jet, because we've got over 1,000 of these jets out there operating in the field today, and operators are going to need to find out what the heck happened. Regarding the configuration of the jet at the time of takeoff and the configuration of the jet at the time that it crashed, well, something has apparently interrupted the retraction of the landing gear system. And remember, we've got a robust takeoff warning system in the 787, just like any other jet. If the crew had the improper flaps selected for takeoff, the takeoff warning system would have caught it. The takeoff flap positions that are allowed in the Boeing 787 is flaps 5 and 15. Flaps 1 only lowers the leading edge slats, and flaps 5 is your more typical takeoff flap setting, and flaps 15 for shorter runways. And flaps 5 on the 787 is not a lot of flaps. With that blended wing, it's hard to see what flaps 5 looks like. So from the grainy videos that we've seen so far, it's very difficult to tell what the flap setting was prior to takeoff and what the flap setting was at the time of impact. But looking at the wreckage, post-crash wreckage, we should be able to get an answer pretty quick as to what the flap setting was. You hear that? That's a husky departing. That sounds just like the rat. Once we look at that crash wreckage, we should be able to determine what the condition of the flaps were at the time of impact. So that's some of the few facts we can tell about this crash so far at this time. Thank you so much for your support of this channel, especially the folks over on Patreon that make this content possible. See you here.